Hey everybody, welcome back to another math video. In today's video, we're going to start talking about transformations in geometry. Essentially what we're doing is we're taking a shape like, for example, a triangle, and we're either going to reflect it, move it in a different spot on a graph, or we might even rotate it. In today's video specifically, we're going to be talking about one of those transformations. Those three transformations are the main ones in geometry: reflections, translations, and rotations. Today we're going to focus on reflections. So let's go ahead and let's get started. Here we have sort of a nice definition of what a reflection is. In geometry, a reflection is a transformation that reflects each point in the pre-image across the line of a reflection. So that word right there, pre-image, it is talking about the original image that we changed. So we either reflected that, we translated, or we rotated. That is what we call the pre-image. Again, today's main point is the reflections. So here we have in the diagram a picture of a reflection. The reflection is the black triangle, ABC. And what you can see is that we've reflected it across this line M, and we get this red triangle. Now, a few things about notations about when we reflect something. So all the points, the original points, will just be a regular letter. So here in the black triangle, we see letter A, B, and C. Its reflection will have the same letters most of the time, but their letters will have an apostrophe. So you can see in the red we have A prime, B prime, and C prime. And those are the ways that we sort of tell which point is which in the reflection. So for example, how do I know which point in the red triangle is point C? Well, that would be C prime. Okay, prime means it's that point after it changed. Okay, and this is sort of how we tell. For reflections, the main key about a reflection and how to make a reflection is that we look at the reflection line, in this case M, and we try to find the distance between a point to that line. So for example, point C is this distance away from M. In order to find its reflection, I must go in the exact opposite direction, but that same distance. So for example, C is this far away from line M. I must go in the opposite direction, the same exact distance, in order to find C prime, the reflected version. And that's why these two lines here have these congruency marks, those two little red lines, because they are the exact same distance. Those two lines are the exact same length, to be more specific. Same thing's true for B. If I want to find the reflection of B, I find how far is B from line M. Well, it's this distance. Go that exact same distance in the opposite direction, and that's where B prime will be. And you'll notice that's exactly why A and A prime are the same point, because A is actually on line M. So if I were to reflect it, it doesn't necessarily move, because the distance away from line M for point A is 0. So A and A prime are actually the same exact point. Now, how do we notate this in geometry? How do we write down that we're talking about a reflection? Well, here we have the symbols. Each transformation has a different symbol, a different way to write it. Most of the times, it's a letter, so R stands for reflection. The smaller letter that's underneath it, this M, that is the line that you are reflecting across. So what this means is I am reflecting across M. I am reflecting whatever is inside of these parentheses. So the way I would read this is I'm going to reflect across M, triangle ABC. So that means I reflected triangle ABC across the line M. Okay, and that resulted in triangle ABC with apostrophes. Okay, with the new image. Another way to write it is if I'm just talking about a single point. What if I just want to reflect one point? Well, I can reflect across M, point A, and I'll get A apostrophe. Okay, we won't get too much into this last one as we're not going to use it in today's video. Alright, so let's go ahead and let's actually try to reflect something first across the y-axis. So the y-axis, in case you forgot, is this line right here, the horizontal axis. This is my y-axis. I want to reflect triangle GHF across the y-axis. And really the easiest way to do this is to go point by point. So first we're going to focus on finding point G when it's reflected. What is the reflected version of point G? So we look at point G and we find what's the distance between G and my y-axis. Well, since these aren't labeled, we're just going to call each space 1 unit. So I can see the distance between G and Y right there, the y-axis, that's just 1 space. So I'm going to go 1 space in the opposite direction of G. So I'm going to move 1 space this way. And that would be the location of my new point G, which we are going to call G prime. So here, right here, I will have G prime. It's a G with an apostrophe. We read that apostrophe symbol when we're talking about it. We actually call it prime. So G prime. Let me write that a little clearer. G prime. Now let's go ahead and then we're going to do the same thing for H. H is underneath right here, so I'm just going to calculate the distance between H and my y-axis, which, similar to G, is 1. So I do the same. I go in the opposite direction 1 unit. And that would be the location of H prime. And now the last point I need to sort of track is F. Let's see how far F is from the y-axis. It's 1, 2, 3, 4, 5 spaces away from my y-axis. So that means I need to go 5 spaces in the opposite direction to find where F prime would be. 1, 2, 3, 4, 5. That's 5 spaces in the opposite direction, meaning that F prime would be here. And I can connect these and now I have reflected my triangle across the y-axis. And this is how we reflect shapes in triangles. Okay? So that's just one type of reflection. That's the reflection across the y-axis. Now we're going to see what does the reflection across the x-axis look like. And you're going to see that the steps are very similar. So let's go ahead and let's look at this. Now I got to reflect across the x-axis. The x-axis would be this horizontal axis. So again, the best way to do this is to go point by point. So first thing I'm going to try to do, I'm going to start from the right. I'm just going to start from L. It doesn't matter where you start from. I'm going to go ahead and reflect L. So L is 1 unit away from my x-axis. So I'm going to go 1 unit the opposite direction. And this point right here is where L prime is going to be. L prime. And we do the same thing for the rest of our points. So now let's find, again, I'm not going in any specific order, it doesn't really matter. Let's do K. 1, 2, 3, 4. 4 spaces away from my x-axis. So I'm going to do the exact same. I'm going to go 4 spaces in the other direction. 1, 2, 3, 4. And this is where K prime would be. K prime. Let me actually put a dot. Okay. So now let's go ahead and find N and M. N is 1, 2, 3 spaces. So I'm going to go 1, 2, 3. And this is a new location for N prime. Now M is 2 spaces. 1, 2. So I go 2 spaces in the opposite direction. And this is where M prime would be. And now it's just a matter of connecting these. So I can go ahead and connect all these dots as best as you can. And this is what the reflection of this shape would look like. And this time we're talking about going across the x-axis. Okay, so this is the difference between the y-axis. Usually you're switching a image from the left to the right or from the right to the left. You're mirroring it that way. The x-axis is from the bottom to the top or from the top to the bottom. That's typically how it goes. Now let's look at one that's not so common or a little bit less obvious, and that's the reflection across the y equals x axis. So that line is the line that goes across diagonally. This is my y equals x line. And this line represents all the points in which y and x have the same exact values. I can pick any point on this line and y will equal x. So now I need to reflect it across this axis. And it's the same technique. We count how many spaces is every letter away from the axis. So for example, let's go ahead and let's start with point J. Point J is 2 diagonal units away from my axis. So I'm going to move that same distance the opposite way. 1, 2. And this would be the new spot for J. This right here would be J prime. Now let's do the same for I. I is 1, 2, 2.5 spaces, which is okay. That means I go 2.5 spaces in the opposite direction. So I'm going to go, here's half, 1, 2. This is where my new I value would be. I prime. And now we find L. L is 1, 2, 1, 2, 3, 3.5. So for L, it's 3.5 spaces. So let's move 3.5 spaces in the opposite direction. 1/2, 1, 2, 3. This point right here would be 3.5 spaces out. So this is where point L prime would be. And now we just have one more point, which is K. So let's go ahead and let's look at K. K is 1, 2, 3 spaces away. So let's go 1, 2, 3 spaces. And this is the location to K prime. And we can connect these points and we get the same exact shape reflected across this y equals to x axis. There's one more type of transformation that we could talk about as a reflection, and that would be the y equals to negative x. But it'd be the same thing, except now the line you're reflecting across is in this direction. But you follow the same steps. If you notice, each of these problems have the exact same steps. Find the distance away from the axis, find how far away each point is from the axis that you're trying to reflect across, and move in the exact opposite direction that same distance. So if it was 3 spaces away from this y equals x axis, move 3 spaces in the opposite direction. Okay? And that's how it works. So hopefully now you have a little bit of a better understanding of how we can actually do these reflections across different axes. Again, this is one of the first transformations we're going to talk about in geometry. But there's also another thing we need to touch on when we talk about reflection, and that is the rules of certain reflections. Now, these transformations that we talked about, we were doing them based off of looking at a graph. We can also work on these if we're given 2 sets of points, and we can talk about, based on what the points look like, what reflection did they perform? So what axis or what line did they reflect these against, and we're going to get into that in this next video. So definitely tune into the rules of reflections video, and as always, I just want to thank you for watching, and I hope that you continue to learn through these.